wondered what really happens when you open a website, send an email, or even watch a YouTube video? In just a few seconds, your data goes on this incredible invisible journey across networks, devices, and protocols. To understand how all that works, we use this one really powerful concept called the OSI model.
All right, so here's our game plan for today. We're going to start with the absolute basics. What is the OSI model? And more importantly, why should you even care? Then we'll take a tour through all 7 of its layers. After that, we'll see how it compares to the model the internet actually runs on, TCP/IP. And then we'll get into something super important, how it's used in cybersecurity. We'll wrap things up by asking a big question. Is this old framework still useful for the future? So let's just pause and think about that for a second. You tap send on a message, right? How does it just magically appear on someone else's screen, maybe halfway across the world? It travels through the air, through miles and miles of cable, and it gets there almost instantly, and perfectly intact. What's the secret sauce behind all of that?
Well, the answer lies in this foundational standard, basically a universal blueprint that everyone in the world agreed to follow. Now, it has a really long official name, the Basic Reference Model for Open Systems Interconnection. But thankfully, we all know it by a much, much simpler name.
So at its core, the OSI model is a conceptual framework. This is key. It doesn't actually do anything by itself. It's not a piece of software. What it does is break down the super complex process of network communication into 7 separate, much more manageable layers. And each of these layers has a very specific job to do. And this is probably the most important thing to get your head around. The OSI model is a reference model, a blueprint. It's not a protocol. It's not a tool. You can't just go and download OSI. Think of it more like a shared language, a guide that helps everyone, from students to senior engineers, learn about, design, and, most importantly, troubleshoot networks when things go wrong. So you might be thinking, okay, why do we even need a model like this? Well, because before the OSI model, networking was kind of the Wild West. Seriously. Different companies made their own stuff, and none of it could talk to each other. It was a mess. The OSI model came along and created a standard, a universal rulebook. It meant that for the first time, different systems could speak the same language, which made designing, building, and fixing networks so much easier. And here's a perfect real-world example of why that matters. Let's say your home Wi-Fi is just crawling. It's super slow. A network tech can use the OSI model to troubleshoot. They can ask, okay, is this a layer 1 problem? Maybe a physical issue, like a damaged cable or interference from your microwave. Or is it a layer 2 problem? Maybe the data is getting corrupted and has to be resent over and over. This layered approach helps them pinpoint the exact problem way faster. So how does your data actually move through these layers? Well, think of it as a two-way street. When you send something, your data travels down the stack. At each layer, it gets wrapped in a new piece of information, kind of like passing a package down an assembly line where everyone adds a new label. Then, on the other end, the receiver's computer does the exact opposite. The package travels up the stack, and each layer unwraps its specific label until all that's left is the original data for the application to use. Okay, let's start our tour of the layers, and we'll begin right at the top with Layer 7, the application layer. This is the one you actually see and interact with. It's your web browser, your email client, the app you're using. In our postal system analogy, this is you writing the actual message and putting it into an envelope. Right below that, we've got Layer 6, the presentation layer. You can think of this one as the network's data translator. Its whole job is to make sure the data is in a format that the receiving computer can understand. It handles things like character encoding, but also really important stuff like data encryption and compression. Then we have Layer 5, the session layer. This layer is basically the conversation manager. It's responsible for establishing, managing, and then tearing down the connection between two applications. It's the layer that makes sure the line is open, keeps the conversation going, and then hangs up properly when it's all done. Okay, moving down to Layer 4, the transport layer. This is a big one. It's all about reliable end-to-end data delivery. It takes the big chunk of data from the layers above, breaks it into smaller segments, and makes sure they all get to the other side safely and in the right order. This is where you find the famous protocols TCP and UDP.
Now we're at layer 3, the network layer. This is the master navigator of the internet. Its job is to handle routing and logical addressing. So it takes those packets from layer 4 and figures out the best path for them to travel across the entire network to get to their destination. This is the layer of the famous IP address.
Next, we have layer 2, the data link layer. Now, if the network layer was about getting the package to the right city, this layer is all about local delivery, getting it from the local post office to the right house on the street. It manages data transfer between two devices that are directly connected on the same network, like your computer and your Wi-Fi router. It also does some important error checking.
And finally, we're at the bottom, layer 1, the physical layer. This is where it all gets real. We're talking about the actual hardware. The cables, the fiber optics, the Wi-Fi radio signals. This layer takes the digital ones and zeros and converts them into physical signals, electrical pulses, light waves, whatever, to actually transmit them over the wire or through the air.
Okay, so we've just gone through this beautiful, logical 7-layer model. But here comes the big twist. The modern internet doesn't actually run on the OSI model. I know, right? While OSI is the perfect model for learning and for reference, the practical model that's actually implemented out there in the wild is its more streamlined cousin, the TCP/IP model.
So, how do they compare? Well, here's the best way to think about it. The OSI model is like a very detailed 7-chapter textbook. It's amazing for understanding all the theory. The TCP/IP model, on the other hand, is like the practical 4 or 5-layer field guide. It's what actually got implemented and became the standard for the internet, mainly because it's a bit simpler and just gets the job done. But, and this is a huge but, this is where the OSI model is still absolutely critical today, and that's in cybersecurity. You see, different types of cyber attacks happen at different layers. An attacker might use an exploit on your browser at layer 7, or they might launch a DDoS attack at layer 4. For security professionals, the OSI model isn't just some old theory. No way. It's a battle map. It's how they understand, detect, and defend against attacks across the entire stack.
And that brings us to a final, pretty big question. Look, the OSI model was designed back in the day, in an era of physical servers and plugging in actual cables. But today, our networks live in the cloud. We have virtualization, infrastructure as code. Things are way more abstract. So the question I want to leave you with is this. Are these classic 7 layers still the right way to think about our networks? Or is it time for a new model, one built for the software-defined future?
Thanks for watching. Like, share, and subscribe.